Picture Earth. 3 billion years ago. It is still a dangerous, dynamic world, a planet alive with volcanic eruptions, violent storms, and shifting continents. But slowly, quietly, a transformation is unfolding. At the heart of that change is a force both distant and familiar: the Moon. By this point in its retreat, the Moon orbits nearly 200,000 miles from Earth. Its tidal influence has decreased from its primeval power, but it's still strong enough to reshape coastlines, control ocean rhythms, and exert its invisible influence on the planet's spin. Over the previous billion years, the Moon's constant gravitational tug has slowed Earth's rotation dramatically, from 6 hours per day to something closer to 18 hours. But this change isn't just mechanical, it is climatic, atmospheric, and biological. The Earth's faster rotation had created extreme wind systems. When a planet spins quickly, it drags its atmosphere with it. The result? Perpetual hurricane-force winds roaring around the globe. These weren't storms that came and went, they were daily life. In this chaos, early life was confined to sheltered areas, deep oceans, rocks, and tiny tide pools. Atmospheric scientist Neil Commons compares the effect to modern hurricanes. When we get winds of 100 mph today, trees are uprooted, buildings are torn apart. But imagine a planet where that wind never stopped. This was Earth for hundreds of millions of years, but the Moon began to change that. As the Moon pulled on the Earth's oceans, raising tidal bulges, friction between the water and the land converted some of Earth's rotational energy into heat. That energy was lost to space, and the planet's spin began to slow. With a longer day came less atmospheric turbulence. Gradually, weather patterns settled into more predictable forms. This was no overnight miracle. It took eons. But eventually, the sky calmed. Winds dropped. Ocean currents stabilized. The atmosphere became a blanket instead of a battlefield. With this newfound atmospheric peace, the surface of Earth began to open up as a canvas for evolution. Larger, more fragile life forms, no longer at constant risk of being shredded by gale-force winds, emerged. Multicellular organisms began to flourish. Over time, these organisms would develop into algae, corals, plants, and eventually animals. And once again, the Moon's influence was critical. The lengthening of Earth's day to 24 hours brought a new rhythm to the planet, a daily cycle of light and darkness, regular enough to shape biological systems. Plants evolved to open their leaves by day and close them by night. Animals became nocturnal or diurnal. Circadian rhythms, internal biological clocks, developed in response to the new day-night stability. This was no coincidence. Evolution thrives in rhythm. Predictable cycles allow species to specialize, adapt, and plan for change. Without the Moon's slow-down effect, days might still last only 8 or 10 hours. There might be no time for rest, no time for photosynthesis, no time for sleep. Earth would be a place of continuous struggle, too harsh for complexity. What's more, the stabilization of wind and water cycles had a compounding effect. As weather grew more stable, erosion patterns changed. River valleys began to form. Lakes lasted longer. Rainfall followed more predictable paths. Ecosystems became structured, allowing food webs and biodiversity to flourish. In this relatively calm environment, evolution kicked into high gear. Over hundreds of millions of years, the first fish appeared, then amphibians, reptiles, mammals, and birds. Entire forests grew, nourished by regular sunlight and manageable climates. And still, above it all, the Moon watched, slowly receding into the sky, its job not yet finished. Even today, the effect of this long deceleration remains. Earth's 24-hour rotation is not permanent. It's still slowing, imperceptibly, second by second. In the distant future, days may grow even longer. But it is the moon that set this process in motion, giving Earth the time and balance it needed to grow intelligent life. To illustrate this interaction, scientists often use a globe and lens demonstration. Imagine Earth as a spinning globe, and the moon as a heavy lens in orbit. The moon raises tides on Earth, bulges of water aligned not perfectly underneath the moon but slightly ahead, due to Earth's faster spin. These bulges act like brakes, pulling backward on Earth's rotation while flinging the moon outward. This gravitational tug-of-war creates a tidal drag, slowly draining Earth's rotational energy and flinging the moon ever farther away. The more the Earth slows, the less dramatic the bulges, and the longer it takes for the moon to continue drifting. It's a cosmic feedback loop, gentle yet relentless. This system also affects the Earth's shape. Without the moon's pull, Earth would be slightly more spherical. But with tides pulling unevenly on the oceans and crust, our planet has developed an equatorial bulge. These distortions influence tectonic stress, ocean currents, and even the length of a year. It's remarkable to think that something as distant and silent as the moon could control so many aspects of life. And yet the evidence is overwhelming. From the calming of winds to the creation of night and day, from the origin of tides to the rhythm of sleep, the moon has shaped us, not metaphorically, but literally. Remove the moon, and you remove the seasons, the tides, the 24-hour day. You remove the early shelter that allowed life to begin, and the late-stage climate that allowed it to flourish. You remove the predictable cycles that trained our brains to sleep, eat, move, and love. So the next time you glance up at the moon and wonder if it matters, remember this: everything about you, your breath, your heartbeat, your very existence, is in rhythm with something that once tore through the sky in a wave of fire and was reborn as Earth's eternal companion.